Let's look at 3.4. We're going to look at something called motion diagrams. And essentially this is just a very helpful way of taking information from a problem and putting it into a kind of a diagram so that you can work with it in a much better way. So the basic idea is that you need to look at certain instances, say initial and final, and there might be more than one, there might be more than two instances. And at your initial time, you want to capture basically three things: your time, your position, and your velocity at your initial time. Then you also want to capture your time, your position, and your velocity at your final time. But then what's happening in between is your acceleration. Okay? So there's initial time and final time. So capture at the initial time, what is your time, your position, velocity, time, position, velocity at your final, and then your acceleration in between there. What is your acceleration? Then you'll notice as well, another thing that's helpful is to draw these dots. Okay? So if these dots between your initial position and your initial time and your final time, if these dots are getting closer and closer together, then that means that you have a negative acceleration. If the dots are close and then they're getting further and further apart, then it means you've got an acceleration in that direction. So let's look at a quick example. Starting from rest, let's just delete this. Starting from rest, a car accelerates for 7 seconds at 3 meters per second squared, and then travels at constant velocity for another 4 seconds. So can you see you're actually going to have 3 points. You're going to have from rest, so you're going to have t initial is 0. Remember, time, position, velocity. Time, position, velocity. What's your initial position? 0. What's your initial velocity? Rest, 0. Okay? Then you accelerate for 7 seconds at 3 meters per second. And then travel at constant velocity. So, time, let's call it time 2. They call it time 1. Okay, let's call it time 1 is then 7 seconds, right? Position 1, we don't know. And velocity 1, we don't know. But what's happening between here is we have an acceleration of 3 meters per second. So we start off with these small dots, or near to each other dots, closely spaced dots, and they increase. So we can see that our acceleration is there, and then our acceleration is 3. Okay, I've run out of space here, but here is the proper example. And then you've got the final time. So this is initial, that's 1, and that's final. So what is my final? So then it travels at a constant velocity for another 4 seconds. So I know my t final is 11 seconds. My final position, I don't know. And my final velocity, I still don't know, but I know that it's equal to my velocity here. So velocity 1. And then what about the acceleration? My acceleration here is 0. So my dots are evenly spaced. Okay, guys, that's the idea here. So go through this, make sure that you understand that. Cheers.